Let's dive together in the fascinating world of fermions. Hey, welcome to Physics Made Easy. Fermions. Fermions are a family of particles which contain quarks and leptons. Leptons are electron type of particles and neutrinos. The third episode of particle physics is about fermions, so we will dive into this world, right? However, there's a lot of things you need to know about them for your exams, so I decided, instead of making a super long video, to make small little videos which will discuss about the different themes. This video will be listing the fermions and discussing their properties using quantum numbers. The second video will be about the mass of fermions, and we will also compare the mass of individual elementary particles with that of the hadrons they build. The third episode will be about quark confinement, the fact that a quark cannot exist by itself but needs to be part of a hadron. The fourth episode will be about antimatter. We will compare two quarks, one quark and one antiquark, and we will look at the differences between them. And finally, the last video about fermions will look at the neutrino, the ghost particle, a very mysterious particle indeed. But for now, let's dive into the world of fermions. We have seen in a previous episode that the standard model of particle physics consists in 17 particles. There are 6 quarks, 6 leptons, and they all group to make one family, the fermions. These are particles of matter. There are also bosons, which are particles of force. They are the carriers of the various forces. And we have the Higgs boson, which is a scalar boson, which provides mass to all the other particles. Now, in the IB physics definition of a fermion, they say it is a particle of matter. Well, it's not exactly true. A fermion is a particle which has a spin which is a half integer, like 1/2, 3/2, 5/2. For elementary particles, the spin is 1/2. So what does spin mean? Well, its definition is within its name. Spin is something spinning, so the particles are actually spinning on themselves. We say that they have an angular momentum. Now, depending on how they spin, there's different ways of spinning, right? So they will have different values for the spin. And the spin is a quantum quantity, therefore it can only take certain values. For example, for the bosons, the spins needs to be an integer number, like 0, 1 or 2. For example, the spin is 0 for the Higgs boson, is 1 for the photon, and is 2 for the hypothetical graviton. This video will be about fermions. We will discuss about bosons in a future video. So, we have seen in the second episode of this series that quarks can combine. Quarks combine and form hadrons, which are combinations of quarks. If I have 3 quarks, I get baryons. And if I form a hadron with 2 quarks, I get a meson. Now you know some baryons, like for instance the neutrons or the protons, which form the nuclei of atoms. All these particles are different. For instance, the quarks have got different flavors: up, down, charm, strange, top and bottom. They are characterized actually by what we call quantum numbers. You know one very well. For instance, the charge. You know that the charge of the up row of the quarks is 2/3, while the down row is minus 1/3. That is a quantum number called charge. There are many different quantum numbers, and we're going to look at these now. Quarks and leptons are fermions. Therefore, they have a quantum number spin equals to 1/2. Another quantum number is the electric charge. It is noted with the letter Q. The up charm and top quarks, the happy quarks, have got an electric charge of 2/3. While the depressed ones, the down, the strange and the bottom, have got an electric charge of -1/3. The electron type of particles, i.e. the electron, the muon and the tau, have got a charge, an electric charge of -1. While the neutrinos are not charged. 0. Another important number to know is the baryon number, noted B. Well, all quarks have got a baryon number of 1/3 because they are a third of a baryon. For instance, if I build up a proton, well, it's 2 ups and 1 down, so it's going to be 1/3 plus 1/3 plus 1/3 equals 1 baryon. On the other hand, leptons are not baryons, therefore their baryon number will be 0. So 1/3 for all quarks and 0 for all leptons. Well, if there's a baryon number, you need to be fair. There's also a lepton number. A lepton number just says, is it a lepton or not? So for the quarks, well, quarks are not leptons. Their lepton numbers is 0. On the other hand, leptons are leptons. Therefore, their lepton numbers is 1. But please note that the lepton number is actually a sum of 3 lepton numbers. The electronic lepton number plus the muonic lepton number plus the tau lepton number. So for instance, for the electron, the lepton number is 1, but it is 1 because it's the electronic lepton number which is 1. While for the electron, the muon lepton number and the tau lepton number will be 0, leading up to 1, right? Finally, the final number that you need to know for the IB Physics exam is called strangeness. Basically, that just tells you that a particle is a strange or not. It tells you if a particle has got the characteristic of a strange quark, or strangeness characteristic. So here, for all quarks, well, the strangeness will be 0, except for the strange quark. So here, 0, 0, 0, 0, 0. And for the strange quark, it will be -1. For the leptons, the strangeness will always be 0. So these are the numbers you need to know, but there are many more. For example, we mentioned strangeness here, but there is also topness, bottomness, and charmness. It just expresses the characteristic of the particle. Has it got some topness characteristics? You see, something like this. So the charm and the top have got a charmness of 1 for the charm and a topness of 1 for the top, while the strange has got a strangeness of -1 and the bottom a bottomness of -1. There is also another quantum number called isospin. Well, isospin is like the electric charge, but for the weak force. So what is actually a charge? In absolute, a charge is what causes a force. Consider, for instance, 2 charged particles. Well, they will repel or attract each other because they have an electric charge. Therefore, it is the charge that causes the force. Take another example. Take a proton, for instance, that you place in an electric field. Well, the electric field will affect the proton because the proton has a charge. But if you place a neutron there, well, the electric field will not affect the neutron. Therefore, the charge is what causes the particle to be affected by a specific force. Now, the isospin is the charge for the weak force, meaning that if particles have got isospin, it means that the weak force will affect these particles. In this video, we listed the fermions and discussed their properties, but we missed one: mass. The mass of fermions will be the topic of the next video. We will do something quite interesting too. We will make a thought experiment where we will compare the mass of the quarks with mass of hadrons. Remember, hadrons are made from quarks. We will find interesting results there. Please check also the 3 other videos, the one about quark confinement, the video about antimatter, and that about the neutrinos. These are really worth it. In the meantime, I wish you good luck with your studies, and I look forward to seeing you soon on the next episode of Physics Made Easy.